We're group 12 and this is our database application. Here's our queries. This first query is called Jason Bateman. What we do is we query the database to get the average cost of all Jason Bateman movies, and then through that we predict if Jason Bateman stars in a movie, what would the budget of that movie be. The next query is actor-director, and what we do is we get this query, we get a average score and average number of votes for an actor and director pair that have starred in more than 5 movies together, and then we get the average score of that actor, and we compare the two and see if there's a statistic significance in the difference of those two means. Next is Zombie. Zombie uses logistic regression to see if there is a correlation between the IBDM score and the year the movie was released. Next is Genre Search. Genre Search gives you a director and a budget. It gives you a director and a budget, and it guesses the genre using naive Bayes. Next is Age Search. What Age Search does is it queries the database for the average score of actors. Age Search takes the average score of actors of all ages and then uses linear regression to see if there's a correlation between movie scores and the age of the lead actor.
So these are the methods for 2 of the different regression models we used. There's a logistic and a quadratic regression. They both take the inputs from the queries that were talked about previously, and then they will reshape the data accordingly depending on which regression it is. And they'll estimate the best fit line for these these data points and plot the points on a scatter plot, and then plot the regression model on the same scatter plot to visualize the differences.
So this is our Gaussian naive Bayes analysis function. We take in data from a query, which is just a table with 3 columns being director, budget, and genre. And we try to use the scikit-learn Gaussian naive Bayes to predict the genre based off the director and the budget of the movie. In the visualization, we have the our t-test visualization method, where it takes in 2 data sets as arrays, and we're also using the scikit-learn t-test here, and it outputs the t-score and the p-value, and we're using SciPy to visualize the t-test by creating histograms for both data sets.
Alright, so here's one of our queries running, the Jason Bateman one. And there it is. Next is the Genre Search. There that is with the naive Bayes. This is our zombie query that should print out a visualization. There it is. And these next 2 actually take a while, so I'm going to run them and then edit it out and show you guys the final what happens. Alright, so this is the graph that we get after we run our age query that has a relation between the IMDb score and the age of the lead actor using quadratic regression. And this is the histogram that we got utilizing our visualization file and the query of the actor-director tuples versus the actor solo score. And as you see, there's no statistical significance between the difference in the means of their average scores and the average work.